A very good morning to all of you. So, I hope I am audible to all of you. Okay, good morning once again. So, this will be our third class for physics, in which till now we have seen, good morning once again. Till now we have seen few basic things, basic points regarding units. Okay, regarding units we have seen, and in the last class, if you remember, don't worry beta, physics is not tough, it is only a state of mind. When we consider anything as tough, if we make a preconceived notion about something that it is tough, then only it is tough. If you will consider it from the beginning only easy and not listen to others who are telling continuously to you that array it is tough, so just listen to yourself. Okay, so it's not at all tough. We are in the present classes discussing the basics, just introduction part. When we will come to the numerical part of physics, then you will see that whatever we have studied now, those points will be used. And I have always been telling that after the class, make a note of the important points. After the class, you can pause the screen wherever you want. At that designated point, you can stop, you can write it down. Okay, so that these things you can remember. Okay, now coming back, in the last class we had discussed about fundamental quantities and derived quantities. I hope everybody can recall that. So fundamental quantities, I said that in particular there is no quantity which is fundamental. Anything can be fundamental. It is anything can be fundamental, depends on what set or collection you have taken. Okay, so what collection of quantities you have taken, according to that you can have fundamental quantities. So whatever fundamental quantities you have selected, based on that any quantity which is derived from these are called as secondary quantities. So let's see through examples. If we consider, say, a collection, I am taking a collection of mass, length and time. This is a set. Can you derive any formula, whatever you can think, whatever you have studied up to class 10th, can you derive any formula for mass only with the help of length or time? Or can you derive any formula for length only with the help of mass and time? Or can you do the same for time only in terms of either mass or length? Please reply fast. Can we have any formula which we can find for mass in terms of length and time, or length in terms of mass or time, or time in terms of mass or length? Is it possible for us? Yes, correct. The answer is no. None of these. So if I am taking this case, none of these can be completely derived from other quantities of this set. So when you cannot derive, therefore above set can be selected or taken as a set of fundamental quantities. So we can select this. Now whatever you derive using mass, length and time, they will become derived. So any quantity derived completely using one or more quantity of the above fundamental set, we will call it as a derived quantity. Any quantity which you can now derive using one or more quantity of the above set will be called as a derived quantity. Now let's see example. I have said that mass, length and time, this set I have taken as a fundamental set. So here if I consider area, now area you can derive using what? Length. You can write area. It is not that you have to write the exact formula, how it is depending on. Area is length square. So area will become derived quantity. If you will write speed, you will write length by time. So you can see that length is also here, time is also here. You can derive speed using length and time, either one or more than one. Okay, so length, time, so speed will also become derived. Speed is also derived, area is also derived here. If I take a quantity, say force, you all would have heard force we write as mass into acceleration, mass into acceleration, and mass is already seen in the above case. Acceleration I can write speed by time or velocity by time, and we just saw speed can be written as length by time. So you can also now write it as mass. If I write speed as length by time, so you will have length here, and you can see there will be time into time, means time ka square. So you can even derive force using mass, length and time. So this will also become derived. So any quantity which can be completely derived using one or more quantities of a selected fundamental set will be called as derived quantity, and those which cannot be derived are fundamental. So fundamental, we have a collection of quantities such that you cannot completely derive any of these quantities, you cannot completely derive from others. But if you can completely derive, then those quantities will be called as derived quantities, like force, area, speed. These are derived quantities for this particular set. Is it clear to everyone? So for this particular set which I have selected, mass, length and time, all the other quantities which I have written examples, area, speed, force, these become derived quantities. Okay. So I will definitely, don't worry, just wait, but I will definitely take question and I'll ask you, and now you will see one more example, then I will ask you that whether it is a set of fundamental quantities or not. Okay. Sir, I seriously can't understand force, mass and acceleration. Better Newton said by second law that force is equals to mass into acceleration. And what is acceleration? Acceleration is rate of change of velocity or rate of change of speed with time. So a empirical formula or a basic formula, we can write acceleration as speed by time. If you can't understand this also, just remember what is the unit of acceleration, meter per second square. At least use meter per second square. So force is mass into acceleration. Meter per second square means what? Length by time square. Understood? Again listen, mass into acceleration. You know acceleration unit is meter per second square. Meter stands for length, second square is for time square. That's it. So you can see mass length by time square can be written for force. So I can derive force completely using mass, length and time in this format. So it is a derived quantity. Is it now clear to you? Okay. So we will now move to, no, we cannot. I think you have not listened to the previous class where I told that not only mass, length, time, I will give other examples. We will see not only mass, length, time, other quantities can also be taken in a group of fundamental quantities. Let's take second example. Second example, if I take, let me know whether it is a fundamental set or not. So I am waiting. First, let me know whether you are able to figure out whether this set is a set of fundamental quantities or not. Is this set, listen to me carefully, many of you are still having doubt in your mind, and I think because of that you are giving wrong answers. Think properly. I am again repeating my definition. Kindly listen to me carefully. I said a set of quantities will be fundamental. Set of quantities will be fundamental only if none, N-O-N-E, none, not that scary movie none, N-O-N-E, none. None of these quantities can be completely derived using any other quantities of that set. So this I am asking, is it a set of fundamental quantities or not? You all are, I am very sorry beta, but all of you are giving wrong answer. All of you are giving wrong answer for this. Tejashri is saying that velocity is derived. Beta, I want you to derive. I will be more than happy if you come with a derivation for velocity, complete definition using only mass or length. Please, I am waiting. Because if this is not clear, later you will have problem, and this is a very easy topic. Kindly try to derive. If you are thinking it is not, kindly derive. Very good. Someone wrote velocity is distance by time. Okay, distance by time, beta, you wrote distance is length. Where is time? Can you find time in this? Did I use time in this set? So that is missing na. Listen to me carefully again and again. When you will be free also, when you will be free, that time also when you think, can you completely derive? Now see, all of your answers will change. All of your answers will change now. Yes, it is a fundamental set. So this is also a set of fundamental quantities because you cannot derive any one using the other. Now let's see. I am taking third example. Let's see. Better don't overburden yourself with so much of thinking right now that sir we have to remember all the formula. Nothing. Gradually when you will see that the course is progressing, things will automatically come to you. If you take things in a tough way, you will always face difficulty. But if you think that what teacher is telling, listen to that instead of thinking too much about what negative things can happen to me, then obviously you will see that if you are confusing yourself by your own, no one can help you. But if you are ready to accept what the teacher is telling, listen carefully, devote your time carefully to the saying of the teacher, you will understand. Tell me fast, mass, time and frequency. Are just a basic thing. Just think that this set is given, select anyone. Those who are not understanding, I should wait for Narayanamma Rayala, or sorry, before that Happy Bob. Okay, not understanding, think, repeating again. Can you derive any quantity of this set? You can see a collection of 3 quantities here. Can you have a complete formula of any one in terms of other? If you are getting a formula, that means it is not a fundamental set. But if you are not getting any formula, means you are not able to derive, then only it is fundamental. Now, yes, now I am seeing lot of correct answers are pouring in. Very good, beta. Here you can see it is not a set of fundamental quantities. Why? See here, because you can see frequency, you all have studied this earlier, frequency can be written as 1 by time. So it got completely derived. It got completely derived using one or more. So it is not a set of fundamental quantities. Is it now clear? Yes. Now all are telling that no, it is not a fundamental set. Is it clear? Very good. Now let us take another. I am waiting. Mass, length, force. I have selected 3. Is it a fundamental set or not? Very good. I can see someone who has given up in the beginning only. If you give up in the beginning of battle, then how will you proceed? Okay, still many are giving no, it is not. Hare, please try to. Those who are telling no, please try to give me any formula. I am waiting for you. Then only I will proceed to the next. Tell me any formula which you can derive for anyone completely. You should have a complete derivation of these terms, any of these terms using the others. I am waiting. I will see automatically your answers will change. So let me write the answer first. Yes, it is a fundamental set. It is a fundamental set. Why? Because try anyone. Try anyone. You will say force. Arey, someone is saying force is mass into acceleration. Beta, please show me acceleration in this set. Have I taken acceleration? Have I taken acceleration here? No. Complete. Listen to me carefully. Complete derivation. Can you completely derive? You will say, sir, we can to write. Okay, right? Force is equals to mass into acceleration. Sir, you told mass into acceleration. Acceleration I can write as length by time square. Sir, you told. So I am getting derivation. No. You are seeing mass here. You can see mass. You can see length here. You can see. Can you see time here? This is missing. So how can you derive? By how can you derive? You cannot. So that means it is also a fundamental set. It is a very to the power infinity times easy concept. Just focus, listen carefully, do the work properly. What you have to do, see the quantities and check whether you can completely derive or not. I am taking such examples which you have heard earlier. So, force, if you write also, you are thinking that okay, I can derive, but you are getting stuck with time. Time is not given here. Understood? So, first of all, if they ask you that I am taking a collection of quantities, can I call this set as a fundamental set? Answer is, I can call a set of quantities as fundamental only if I don't see any term getting completely derived. Is it clear? Shall we move to next question? Okay. I am telling, definitely it is a very easy concept. Some students are now writing, sir, it is very easy. Yes, it is easy. Things are just in our mind. We can perceive anything as easy or tough. If you want to do good in your life, always have a positive thinking. Think that things are going to be easy. That's it. Let's see next. Okay, tell me the answer for fifth one. Fifth one again. Yes, it is a fundamental set. You cannot derive. Sixth one, mass density area. Can anyone say sixth one, mass density area? And if they are saying yes, then why? And if no, then give me a reason for sixth one, mass density and area. Okay, this set is not a fundamental set. Let's try to prove. How we can prove? See, can I write density as something? As you all know, I want to hear from you so that it will be clear to all of you. Density, what I can write? Mass by volume. Very good. Wait, you will come to know. Mass by volume. Is it clear till now? Okay. Now let's see. You will be surprised now. Can I write area is equals to length square? Don't tell me, sir, we have to study 4 pi, 3 pi r cube and all. I am just asking the relation between the physical quantities. Can I write area is length square? Please tell me fast. Area is length square, is it correct? Okay. Can I write volume is equals to length cube? So can I write, if area is length square, can I write length is root area? Length can be written as root of area power 3, means it becomes area power 3 by 2. Check fast and tell me. Okay, so see what we are getting. So density I have derived now as mass by area to the power 3 by 2. So you got a complete derivation of density using mass and area. So since derivation is possible, that means it is not a fundamental set. I am not asking you to use an exact formula. I am asking about the dependence on the physical quantity. Volume is related to area. Area to the power 3 by 2, because volume is length cube. Area is length square. So volume can be written as area to the power 3 by 2. So if area to the power 3 by 2, so density can be written expressed as, yes, mass and area to the power 3 by 2. It is an empirical formula. Empirical means basic formula. So this is what you will get. If you want to cross check whether sir is telling me the correct thing or not, those who are, please stop typing others, and those who said didn't understand, kindly tell me, I am waiting for you. Can you tell me the unit of density? Those who are telling, please explain again. Can you tell me the unit of density? Then I will show you whether it is coming or not. Can you tell me the unit of density? All your sambar, rice, chutney you can explain later. Presently I am asking, can you tell me the unit of density? Okay, you know that very well, kg per meter cube. So in left hand side, this formula I have written kg per meter cube. Now come to the right side. Right hand side I have written mass by area power 3 by 2. Tell me the unit. Can I write for mass kg? What is the unit for area? Do you know? Area is meter square. Can you see the power 3 by 2? Now check what you are getting. Kg by 2 cancels, meter cube. Can you see LHS, RHS are having the same unit? Are you able to see LHS, RHS are having the same unit? That means density can be expressed in terms of mass and area also. So we can get a complete formula, an empirical or basic formula in terms of mass and area. So since we are able to derive one of the quantities using other, so it is not a fundamental set. Clear? Okay. So let's move on. So now you saw the reason what I told in last class. Let me make you remember that if we have infinite possibilities of selecting fundamental quantities, so it will become very difficult for the world to survive together, because every person will say, who has learned physics, why can't I take force, velocity, time fundamental? Someone will say, why can't I say mass, length, time fundamental? They will all fight with each other. So that's why I told in last class in the end that to avoid this confusion, internationally 7 physical quantities were selected as fundamental, and all the other quantities which are derived from these are called derived quantities. So if again one more time I will say, it is not mandatory that these 7 are only the possible fundamental. What I am going to write, they are internationally accepted. So we use them in normal language. When we are asked that tell me fundamental, I say mass, length, time. But it cannot be ruled out that I can take force, velocity, time also as fundamental. Understood? Other examples also I took earlier, I can take them also fundamental. So, but to avoid any confusion, we all should read the same physics everywhere in the world. So, we are using an internationally accepted set of fundamental quantities which we will be writing here. So, what is that? Internationally accepted set of fundamental quantities have 7 quantities in total. I am going to write the fundamental quantity of that set, and what symbol we are going to use for them. The fundamental quantities are mass, length, time, temperature. You give your whatever effort you can never derive any of these from the others. Temperature, current, amount of a substance which is called as a mole, and one is luminous intensity. Don't get fearful of the words which you are seeing at the end. Arey sir, what is this? What is that? These all you don't have to study. At least luminous intensity you don't have to study now. You have to mainly focus on the other terms which you have heard of. For mass, symbol capital M, length L, time capital T. All the standard books for representing these fundamental quantities. Temperature, we won't use T because T is reserved for time. For temperature you will see either they will use K or theta. K is just to give respect to the scientist Kelvin because of the unit of temperature Kelvin, or we also use theta. These two symbols are used to denote temperature. For current, you will see in some books capital I, and in some books the unit of current which is ampere, so capital A. Amount of a substance you study in chemistry. In physics also there is a separate chapter dedicated, there you will see. Luminous intensity, we have the unit of luminous intensity. Based on that the symbol is given CD, which stands for candela. So luminous intensity you have CD, which stands for candela. So these are the fundamental quantities which have been internationally accepted, and all quantities which are derived from them, they are derived quantities. Is it clear? Now one more important thing which I would like to mention over here, these are the internationally accepted fundamental quantities, and I said any quantity which is derived from them are derived quantities. But now wait, these three, mass, length and time, whenever you will read the history of physics, you will understand that earlier all the calculations made in physics were based on mass, length and time. talking about the time of Galileo and all, when current was not discovered, that time people only found calculations based on mechanics, mass, length, time. So remember, out of these three, any quantity which depends completely on any combination of mass, length and time only. Those quantities which depend only on any combination of mass, length and time only, these are given names, we call them as mechanical quantities. Whichever quantity will depend only on mass, length and time, they are called as mechanical quantities. Is it clear? So any derived quantity which will be fully dependent on m, l or t only, these are called as mechanical quantities. Okay. Definitely in the next class we will be seeing dimensional formula, so that conversion of units and all will be clear to you. But presently what I am talking about is mechanical quantities. Listen it, we will be gradually step by step moving to the next section. Okay. And the more you attend sincerely the classes, it will be better for you and you will be able to understand also. If you are involved in talking to each other and discussing your personal lives over here, so it won't help you in understanding physics. Then to beta later also you will feel the same. After 2 years successfully passed, you will feel that array I did not understand anything because I was busy talking to others. So focus here, it will help you. So mechanical quantities are these. Now we come to what is called as units. We talked in the beginning that whenever we want to give a meaning to a mechanical quantity or any physical quantity, we attach something called unit. And I explained also which unit is more, which unit is smaller, everything we have discussed. I hope everybody remember that. So now when we are having these fundamental quantities, so there should be some specific units. There will be some specific units. Okay, someone is asking when does you start lesson, sir? Unit and measurement. This is our third class. You can attend the 2 classes which I had earlier discussed. Okay, we will do differentiation and integration, we will do everything. We are just starting with the basics. Don't worry, everything will come. Have patience. Okay, when your mother cooks food for you, once she has cooked the food, then you taste it and enjoy it. It's not that the food is raw, you have raw vegetables or raw meat and you start gulping. You don't do that. You patiently wait for her to complete the food, then you enjoy it. Similarly, don't be in a hurry, array we will study differentiation, integration, this, that or not. Everything will come step by step. Focus here now. We are talking about units and dimensions presently. So now when we talk of systems of units, so based on the mechanical quantities which are dependent on mass, length and time, we have systems of units. First system we take MKS, second one we take CGS, third we take FPS, and the fourth most important we take SI. Now what is the feature of these three, MKS, CGS and FPS? This gives units on mechanical quantities only. Means it will, these three systems, MKS, CGS and FPS, will give you units only of mechanical quantities. Mechanical quantities are which are derived from mass, length and time. So what it uses, as the name goes, M is meter for length, for kilogram you are using for mass, for meter length, and S stands for second, which you are using for time. So I said any quantity which is made up of mass, length and time, their units will be given by MKS, CGS and FPS. Now, next one, this is also giving you units of mechanical quantities. Only the thing, C stands for centimeter for length, G stands for grams for mass, and S stands for second for time. In British system, FPS, this also gives you the same. F stands for foot, which we use for length, pound, which we use for mass, and here also time, same, second. So these are the three systems which gives you units only of mechanical quantities. Just as an example, I am removing your confusion. Listen here, stop wasting your time. Example, if I take force. Now I told you force can be written as mass into acceleration, and I said you can further break it into mass, length and time as mass into length by time square. This we had discussed today in the beginning only. So if I am asked MKS unit of force, what you will write? For mass we have kg, for length we have meter, and for time we have second, so second square. If they will ask you CGS unit of force, again see, for mass you will use gram, for length you will use centimeter, second square. If they ask you FPS unit of force, so you will say pound, foot per second square. So these are mechanical quantities. These are mechanical quantities and these depend only on mass, length and time. So MKS system, CGS system, FPS system, all the three will give you the units of any quantity which is completely derived from mass or length or time or any combination. So as I said, force is mass into acceleration, acceleration is speed by time, so we can write mass into length by time square. So MKS unit of force will become mass kg, length meter, time square, second square. And CGS system, mass gram, length centimeter, time second square. And FPS system, mass pound, length foot and time second square. Is it clear to everyone? So we are running short of time now. So we'll be stopping the class over here, and in next class, kindly please, it is a request, those who could not understand or had some confusion, it is a request, please attend the class, at least listen the class again, and see what all points I have said. if possible here 3-4 times, then you will be able to understand what we have done. So tomorrow we will see that how we can use these systems of unit and SI. I did not explain anything about SI today. SI we will see tomorrow, and then we will see why we are studying all this, what is the benefit, how we can use in conversion of units, and what is dimensions. We will be introducing that also. So please be patient in the class, listen to what we are telling instead of involving yourselves in unnecessary banter which is going on with some of the students. So please be sincere. Physics will be very easy if you sincerely read it. So that is all I can say. Thank you. Have a good day.